Hello there, geometry people and friends. Today we're going to do the distance, lesson 10, unit 6, the distance from a point to a line. Now we'll start off by doing this on a graph, and eventually we'll have to do this without a net being a coordinate graph. So what we're going to do first, making sure this is recording. Okay, good. We're going to do first is graph line AB with point A at 2, 1. And point B at 12, 1. Now this is a nice, neat horizontal line, easy to count how long it would be, but this is a line, so actually I guess I should adjust my picture because a line should not have endpoints. A line goes forever and ever, just like the king from Hamilton. Forever and ever. Okay, sorry. Right, back on task. Write the equation of the line. Which is easy. The equation of the line is a horizontal line, so it's just y equals 1. And we want to know if point P is at 9, 4, how far is point P from point A? So use your distance formula, pause the video, use the distance formula to find the distance from P to A, please. So our distance, we can just leave it as radical 58. Now pause your video and use the distance formula to find the distance from P to B. So that's 3 radical 2. Simplified or not, we can tell that the distances are not the same. So if I were to ask you, how far is point P from line AB, how do we know to figure out exactly how far it is? Because the distance from P to A was different from the distance from P to B. So how do we know how far P is away from AB? What's the shortest distance? How do we know what the shortest distance is? Well, the shortest distance between 2 points is a straight line, not a line that's at a certain angle. So point P is 3 units, 1, 2, 3 units away from line AB because you would measure perpendicular from the point towards the line. So that means we could just count straight down to line AB, 1, 2, 3 squares. So point P is 3 units away from AB. So the shortest distance from a point to a line has to be measured perpendicular to that line. Now, the shortest distance from a point to a line is a measured perpendicular distance along a line normal to the original line. Normal means perpendicular. So if you're trying to find the distance from a point to a line, you have to find the perpendicular distance from the point perpendicular to the given line. So we have to use perpendicular slopes. Distance using the graph. Okay, so how far is the line y equals 5 minus x from the point 1, 2? So graph the line because our slope will be negative 1. Y-intercept is at 5. There's the line for y equals 5 minus x. The point 1, 2. So we are supposed to measure perpendicular from the point to the line. That means if our slopes are perpendicular, the slope of the normal line, which means the slope of the perpendicular line, will be positive 1. So I need to find a slope of positive 1. Using a slope of positive 1, I need to find where the line perpendicular to our given line that passes through the given point, I need to find where that intersects the original line. So we need to find the point of intersection between the line that's perpendicular to our given line and intersects the original line. So I drew the line through the point 1, 2 that is perpendicular to the given line. That means I find a point of intersection at 2, 3. How do I know that? Because that's where the two lines intersect. Okay, so what we're trying to do is find the distance from the point to the given blue line. I drew the perpendicular line through that given point and found that the two lines intersect at the point 2, 3. So now I'm going to find the distance from the point of intersection to the point that we want to find the distance from. So I'm going to find the distance from the point 1, 2, which is the given point, to the point of intersection where the two lines cross. That'll be the distance between the point and the line. So the distance from the given point to the given line is radical 2. Again, what I did was I plotted the given point, took the original slope, made it perpendicular, graphed a new line. Then I found the point of intersection of those two lines and used that point of intersection in the distance formula to find my answer. All right, so let's try again. How far is the line y equals 1/2 x from the point 5, 0? So if I graph the line y equals 1/2 x, that means it has a y-intercept at 0, up 1 over 2, up 1 over 2, up 1 over 2. I have my line graphed. From the point 5, 0, that is right on the x-axis. So if I want to find the distance from that point to that line, I need to draw a line perpendicular to the original line, but passing through the given point. Then I'll find the point of intersection of the two lines, then apply that to my distance formula. The slope of the given line was up 1 over 2. That means the slope of my normal line, and normal means perpendicular, the slope of my normal line will be negative 2 over 1, or negative 2. So I'm going to go to the point 5, 0, and draw the line with a slope of negative 2 through that point. I'm using the graph to find the point of intersection of those two lines, so then I can then use the distance formula between the point of intersection and the point 5, 0, the given point that I was supposed to find the distance from. So when I plug those numbers into my distance formula, I am going to find the distance from the point to the line. It's actually the distance between the point of intersection and the given point, but that point of intersection is on the original line. So my distance is radical 5. That is the distance from the point to a line. We have to use the distance formula to find the distance from the given point to the point of intersection. The equation of our new line using the slope of negative 2 and passing through the point 5, 0 could be written several different ways, using point slope form, simplified point slope form, or slope intercept form. Now here's what's going to happen to you in your future. You're going to have to find the point of intersection between the two lines without a graph. So to do this without a graph, you would take the two equations and you would somehow do some sort of substitution or set them equal to each other. Once you solve for x, you can then find y, and then you'll end up with the same point of intersection that we got off the graph. We will not always have a graph available to us, and sometimes the point of intersection may include decimals. If they're not nice, neat whole numbers, we wouldn't be able to get the point of intersection from the graph anyways. So we have to be able to use our algebra skills. So one of the equations was y equals 1/2 x. The other equation, after we simplified, was y equals negative 2x plus 10. Since they both are equal to y, I put them equal to each other. That's how I got this first green equation. Y equals 1/2 x and y equals negative 2x plus 10. Since they both equal y, I can substitute and put them equal to each other. Then I solve for x, get my point of intersection. Okay, so find the distance from the point 7, 2 to the line y equals 3x plus 1. So the point 7, 2 and the line y equals 3x plus 1, that means it's a y-intercept of 1, a slope of up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. What we need to do is find the point of intersection between the normal line, that means the perpendicular line, through the given point. And once I find the point of intersection, I can do the distance formula from that point to the point 7,2. So when I graph my perpendicular line, it'll have a slope of down 1 to the right 3. So working backwards, I can go up 1 to the left 3, up 1 to the left 3, up 1 to the left 3, until I get the accurate exact point of intersection. Once I have the point of intersection, I can then use my distance formula. Since I know the distance formula so well, we can just plug it into our calculator. Once we get the distance from the point of intersection through the given point 7,2, then I can reduce it, simplify, and move on to the next question. Okay, so when you're asked to find the distance from a point to a line, you find the distance from the given point to the point of intersection between the given line and the line perpendicular to that through the given point. So now you can go to your problem set, practice using the answer key to make sure you're practicing correctly. If there's a graph, great. If you can't get an accurate point of intersection, you may have to use algebra. We are going to do some more practice tomorrow. And then, actually not tomorrow because you guys are on spring break, but we will do some more practice when we get back. But this is the last lesson of the unit that's not review or practice. So now it's just to make sure you know everything so that we can test out soon. All right. So well done. Good for you for coming. Thank you for listening, and be good to each other. Be good to yourself. Stay safe. Goodbye.